Finally, the video begins, or he posts the video, right? Let's go ahead and jump right into it. So, so when it comes to the file, watch everyone do it like on Monday nights. They don't even do it. That'd be funny. Chapters. We're looking at chapter 5. I think it's chapter 5. Yeah, chapter 5. I think it might be. Yeah, this doesn't matter. Um, Here, what we're going to do is talk about strings. Really, we're not really working with strings. In R, it's really called characters. But still, we're not even working with characters, we're working with factors. Okay, so a string, actually, without context, it has no, we don't even call it strings in R. So we call them just chars, characters. But chars in it of themselves, they don't necessarily have inherent value. One char, one character doesn't mean more than the other. And so what we can do is, like, and I mentioned this in class, we can do with characters as if they're factors and have certain meaning behind the levels of a factor. So let me make this make more sense by looking at some examples. So I went ahead and said, you know what, we can still work with NYC data, the flights data, but I'm gonna do a look at a little sample of the data, not the entire data set. So the premier data, for at least technique we're going to talk about, is forcats. We're also going to talk about time here, but not too much. Okay, and we need dplyr to make some data transformations, and we also need, which I didn't add, but you all can add as well, is library gg plot2. We're going to need that. I could have done this with tidyverse. This would have taken that, and that would have been within tidyverse. Lubridate's not within tidyverse, but here and there you can mix and match. Okay, so boom, run this, let it give me its emotions, all the warnings. Okay, exit out of that. Okay, and so again, forcats allows us to give meaning to the levels of our char, of our character, of our categorical variable. Okay, so what we're going to do is take a random sample, okay, of 1,000 rows from the flex data frame. So therefore, I don't have to look at every single row. It's a 300,000 row data frame. I don't have to look at everything. And I'm also going to only focus on two variables, carrier and depart delay. And I'm only going to consider these particular levels within carrier. So I'm just going to change this to n. So how many rows should this data frame have? Ideally 1,000. How many columns? Just 2. So we go to environment, we see nothing. When I run this, I should see it 1,000 by 2. Don't embarrass me. Why is it not 1,000? Let's run that again. That's very interesting. Oh, Dr. Williams. Because I'm nervous when I make videos. It's fine. Everyone gets nervous. If I run this now, it's going to have 1,000. Ta-da! And then when I make the filter and focus only on these carriers, because I don't want to make it too large of a data frame, I have 551 this time, because this set seed allows me to have a random sample. So if you run it once, we should all have the same data set. But since I ran it twice, we don't. I'm going to restart R just so that we can have the same data frame to an extent. So restart this. Hopefully, should get 553. What was it? I think 553. So we're going to run. Is this in setup? I'm going to call this setup so you don't restart it. And when I run this now, 553 or 535. That's what we had last time. Okay, good. So if we view this, we only see the first 2 columns and 535 rows. Nothing new. The only thing that should be new is sample n and set seed. Okay. Let's group by carrier. Okay, in this little demonstration here, just for us to see what's going on in terms of the data before we work with factors, or factor. So I'm going to group by carrier. Okay, and I'm going to find the max departure delay. So ideally, there should be 1, 2, 3, 4, 5, 6 rows, 6 observations, and two columns. Exactly. Some of y'all didn't know to do that on your oral quiz. Okay, so be aware of that. Okay, and so this is the ordering, and a student pointed out to me that Dr. Williams, this is naturally in order. So it's doing numbers, then it's doing letters. So that's the order that's provided. It's not the order of the median. So the highest median is AA, and then the lowest is -3, but it's really being ordered by numeric then alpha, numeric then alpha, and then the alphabet. Okay, and so the point that I'm trying to make here in terms of factor, using these factor functions, these FCT forcats from the forcats library, we're able to specify the order ourselves based on certain criteria or based on what we want. Okay, so what do I mean by that is visual lies. Nervousness is serious. So if I haven't done anything yet. I'm just showing you what this data looks like in terms of aggregating it as well as visualizing it. Okay, so this is the natural order, and again, it's ordering from left to right in numeric alphabet order. Said it right that time. All right, good. So what I can do is, let's say for example, I don't want that. I want it to be based on I said median. Should be max. It should be max. Sorry about that. Max departure delay, and ideally I want it to be ordered based off of the max number and then in descending order. Okay, and so what I would do is use the following code. So I'm going to mutate carrier. Okay, so I'm going to create a new variable, and which is going to be called carrier. I'm going to keep it the same name, and then I'm going to use FCT for factor reorder. So I can reorder it, right, based on the departure delay. And I'm going to erase something. No. Okay, I'm going to keep it, and then I'm going to have it work, and then we'll go from there. Okay, so it's being reordered based off of the max. Okay, and it's going to be in descending order. So it's going to be from max all the way to the smallest. So when I run this, no change because there's no visual. But now when I run this and do a geom, what geom should I use? If you said box plot, good job. Okay, now it's AAMQDL. So remember, it is AAMQDL. Okay, so what do you think is going to happen? Let's see if I remove this descending order. What should happen? Okay, let's remove it. Okay, say your guesses out loud so your roommate is upset. I don't know. All right, so ideally I think it should be HA, then the other 9E, and so on and so forth. HA 9E. Okay, now what if I remove this and they remove? What do you think is going to happen? I think there's going to be an error. Or if not an error, it's going to be a warning. Okay, a warning that NAs. And then let's see how, I haven't seen how it actually is being handled. Let's see how it's handled. It still works, but it's going to be in that original. It does still work, but ideally to get rid of that error, what you'll do is provide the NA remove. Okay, now let's say we wanted to do it by standard deviation. Okay, I didn't try this before. We'll see. I'm gonna embarrass myself. It's fine. I would say based on standard deviation, AA should be first because there's a lot of variability. Then MQ. Oh wow, it's gonna be almost the same thing. Okay. Really? And is this in descending order? No. That's very interesting. We can just double check that just so we can see for funsies. SD is equal to SD DP delay NA dot remove is equal to true. Someone can ask me, oh, Dr. Williams, why is it NA dot remove here and then NA underscore remove here, right? It's because as time progresses, how tidyverse works, they progress in the code and they prefer using underscores rather than using dots. And the dot is from a previous iteration or previous version of R. Okay. That makes sense about HA. MQ has the largest variability. Interesting. Okay, so then it's MQ then AA. It's MQ, and then AA. That's right. Okay, that's good. Okay, that's fine. And then we can do ascending if we can do descending if we like. Right now it's ascending to the largest, and this is NA because it doesn't have variability. All right, it's enough about reorder. Was it reorder? Yeah, reorder. Let's do lump. So lump, I actually like this. This is quite interesting. All right, so here we're going to lump carrier. Okay, we're going to do carrier. Turn off insert. Oh no. This is okay. Let's see what it looks like. This is before we do any of the lumping together. Okay, this is what it looks like. All right, before I do any lumping, I'm only looking at one variable here. This is a bar plot. Okay, that's fine. That's fantastic. I'm using theme custom from Godot 365. That's fine. That's cool. That's fine. Now the thing is, I can aggregate certain groups based on my max number, or even I can lump them together based on the minimum number. What I mean by that is I wanted to have the top 3 groups be represented, and then the other ones to be labeled as as other. All I have to do is do a lumping, right? If I do this function here. If I do lump, LUMP, this will have 4 bars where it should show AA, B6, DL, and then 1, 2, 3 is going to be considered as other, HA, MQ, and 9E. So let's do that. Run this. Okay, AA, B6, DL, and other. Like I said, okay, that works. But that's no fun. Let's do the smallest 2. Okay, the smallest 2. So what I want to do is have HA and 9E show, then everything else is going to be considered to be other. That's what the minus allows us to do. Okay. See? Easy peasy. Factor. FCT. Okay. Reverse, this is not that serious. We can reverse the order. So then this is the original. Okay, this is the original. That's what it looks like. Well, we can reverse the order, not recode. I'm pretty sure it's not that, but it is just rev. Okay. So here, now I can reverse the order, and now instead of starting at 9E, it's just going to start at MQ. I don't like this one that much. It's not that impressive. It should start at MQ. Let's see. MQHA. MQHA. So it's not too crazy. That's fine. Moving right along, let's reverse. Let's do infrequent. So we can do the most infrequent. So this is just going to order it from least to greatest. So if you do this, it's ideally should be HA to 9E, then MQ, and so on. So these little things allows us to just move through our code a little bit more easier, at least in terms of having to recode this. Back in the day, this was not as easy. Not as easy at all. Because how are you supposed to specify the actual ordering of these letters? in terms of computer, it's just gonna, not letters, but in terms of these characters. In terms of these characters, the computer doesn't know which one's greater, so it just says numbers then letters. So now we're able to order these bars based off of the frequency or some other designation that we're interested in evaluating. All right, so re-level. One that I wish I did do, I didn't get to do, which is fine. This is re-level. I'm gonna think of it, it's recode. Recode is, I might do that and embarrass myself, but I'm okay with it because it's actually that cool. So re-level is what we're going to change. So what we're going to do is we're saying start off with DL then HA. Start off with DL then HA, and then show the rest. So it's going to have this one then this, then should start at 90 AA B6 and so on and so forth. DL, let's see, DL HA 90 AA B6. So I love this. I get to teach you all how to use something that's really important. Okay, so I want to learn how to do recode. I was saying that in between me teaching you about relevel. If I want to learn how to do this, I'll do help, and I'll do FCT underscore recode. Okay. All right, so then I go to the help desk. And this is where a lot of information can be very, very useful. So this is actually really nifty. So it tells you what it is. Okay, so change factor by levels by hand. Okay, and so I can not automatically tell you, but I can tell you that what this is doing is actually allowing you to change the actual level. It's not allowing you to change the actual level. So let's go ahead and just copy and paste this. Boom. Run this. Okay. So I would say the output should be, can anyone guess what the output would be? I believe it's going to be banana, bear. Oh, yeah, it should be banana, bear, banana, deer. Interesting. Okay. Where in fact it only has now just 3 levels. Okay, so we can actually just print out X. Okay. So you can see at first there is 4 levels, okay, 4 different options. Now by me just changing apple to banana, it now only has 3. So someone can easily say, Dr. Williams, what if you didn't do it this way? This is not Python. Okay. What if you did X indices? Okay, we index at 0, at 1, not 0 like Python, and define that to be bear. Okay. Watch this. It's still gonna have apple. It's still gonna have apple, but it's gonna still show not bear. Let's say banana, so we can be consistent with our previous. So when I do this, it's gonna say banana, bear, banana, deer, but still have apple as one of the factors. Let's say print X so that you can believe me. So you see what I'm saying? So it has apple, bear, banana, deer, this first one. And then when the levels include apple, but then when I change the actual value, it changes in the data, but it still considers apple to be a level. And so what's problematic about this is that if you were to graph this data here in terms of frequency, it would show apple as 1, 2, 3. It would show apple as a level with no data. Okay, so you don't have to deal with that when this happens. Okay, there's a way for me, because I think it definitely does have 0. There's a way for me to remove this using factors as well. But because of time, I'm almost certain I'm at 17. I'm going to go on to, I have to press pause there. I'm at 19. Okay. All right. So here, lubridate's kind of, it works with time. We're working with time in dates. So you have time as in like hours, minutes, seconds, and then date as in days, months, years. And so what I'm gonna do is I'm gonna take the flights data, and I'm gonna only focus on these two variables, day and time, and take a sample of 1,000, and this should only have 1,000 rows. Okay. Oh, I made a mistake. What happened here? And select. Flights. Date type. Okay. I meant to just look at one variable. My apologies. Oop, this should work. Boom. Okay, 1,000 by 1. Okay, great. Fantastic. Here we have our dates and we have our hours, minutes, and seconds in military time. Hours, minutes, seconds, year, month, day. Okay. My apologies for that. That variable doesn't exist yet. I'll create it in a little bit. All right. So with that being said, some main functions, some really key functions within lubridates for us to actually get our characters into a date format. So what I mean by that is that this is a character. You don't right now, computer doesn't know what this means, but when I actually apply this function YMD, right, this gives me a particular format, flight date, right, that we can see. So come to find out, if you do class, so we haven't got to emphasize this too much, we can actually specify, well, not specify, but understand the type of data that we're dealing with here. Yeah, come on. So the date type. But if you were to do this before, if you were just to use, I'm just going to call this date temp, right? And I did class of date temp, it's a character. Okay, so we are able to specify it as a date. However, not all the time, every single time your data is not going to be in this particular format. Let's say it's month, year, date, month, day, year. You can utilize MDY, and so that should work as well. Run that as well. Sorry, should have been 1 and 2, but still the last one was ran, so therefore this is going to be shown. If I show this, it provides it in the same format as before. All right, and we're going to do class. Let me illustrate even more so you can agree with me. Okay, so then if I do class, it should still say date. Flight date. Good job. And so again, this is all within. This is a cousin of tidyverse, lubridate, which is nice. The reason why I bring that up is because the syntax is very similar to dplyr, where they have like tidyr, pivot underscore functions, and so you will see more of that even within lubridate. So here we can actually extract various elements of this information. Okay, so remember, this is the date information, this is time. Let's say I just want to get we're gonna work with just dates for a little bit. Sorry. If I wanted to figure out the actual day of flight date, which is this information here, if I view weekday, this should tell me whether it's what day of the week it is. Okay, what day of the week it is. And it also automatically gives the levels and it specifies the order. So Sunday starts first, but you can reorder this with the FCT, one of the FCT functions. We can find the year by simply doing year. Okay. Actually, before I do that, if I say label is equal to false, for example, which is the default, I believe, this legitimately should show up for weekday. If we said 3, You're correct. Okay, because it's the third day. So that's cool to see. For year, this should just provide the year, which should be 2024. And someone came to Learning Hours one day. I think I'm going to take advantage of this time and tell you. But someone came to Learning Hours, and I didn't emphasize that. Nor do I do it in most of my videos. I don't emphasize using the console as a temporary place for me to do quick calculations, because I'm not going to use or save this information that I do here. So I might as well just run it here so that we can see it. Okay, and we can also extract the month. And same false and you can also do something else with that month function. Same in regards to day, at least. You see it says January, it's abbreviated. I can say abbreviated is equal to, I press tab, you can see, and I said abbreviation is equal to, is it true? I think I should say false. Okay, let's run that. And then it should say January. Okay, good. All right, so that's working with dates. Time is a little bit tricky. So there is a format within R called POSIX XCT and POSIX LT. I would say, okay, so POSIX is a count of seconds since some dates, usually 1970 January 1st. And then POSIX LT is a list of time components. Date is for dates only. Time can be kind of tricky. Going into deep detail here, I won't be doing that in this class. But when you go deeper, I won't even think 431 will do this to an extent. Okay, so that's fine. All right, so here, and I haven't taught you this, but I at least want you all to be familiar with this. This is, in and of itself, the very first line creating a new variable. And I want you to change something. All right, so this is the data frame that we're working with. And this is what we're going to analyze. Okay, good. So what this little doohickey here on the left is doing is creating a new variable within sample time New York flights DF called date type. So right now that data frame, New York time, is 1,000 by 1. When I run this, it's going to now have 2. But what exactly is it going to do? It's going to create a variable, again called date time, where a weekday, let me zoom out. Oh wow. Weekday is our function. So it's going to find the weekday. I'm zooming out so you can see more. And it's okay. So it's going to take the weekday from this particular variable and then label it true. So let's go ahead and just run this so we can see that it works. So it should just give you the weekday, whether it's the day of the week. So Monday, Tuesday, Wednesday, Thursday, so on and so forth. So you can see now it has 2 columns, right? And it has a day of the week. Great, fantastic. From there, I'm going to re-level this. Okay, and I think I did that. I mentioned re-level. Oh, I did, didn't I? Was it one of the first ones I did? I already forgot. Reorder. I don't think I did re-level. Well, re-level allows us to essentially create a new or aggregate the levels together. So when I run this now, it's considering Saturday and Sunday, and then finally when I run this again, I'm getting all right. All right, it's gonna be random. That was a pause in the video, so that's fine. All right, so what I'm gonna do is I'm gonna run this and show you what's happening here. And if I were to just display, if I just copy and paste and show this here, it's going to show me the levels. Okay, it's going to show me the levels, but it's going to have a particular order, right? It's going to have, it should say Sunday first, right? Sunday first. But let's say if I don't want that to be the case, I want to have Saturday first. That's what relevel is doing. So if I run this now again, if I stop pressing buttons, I'll run this again. It has Saturday first. Yes. And then now this is lumping together, saying based off of frequency, the two most frequent groups, and then other. Okay. And then you're gonna consider the other as a week. This is not good code. Because how do they know that the other is gonna be Sunday and Saturday? That's okay. That's fine. Let's keep going. We're almost done. And then here we're gonna group by average delays by date type, which is this date type, and then display it here. So let's go ahead and run this. Does anyone know why this is an issue? Because I didn't keep this variable. So let me put this variable right here. Do that. I shouldn't change much. And run this here. I can't believe I figured it out that fast. Okay. All right, so here we go. So Wednesdays and Thursdays and every other variables in this group because they're not as frequent. Okay. But if I were to let go of this statement, this factor lump, not that one, this one, and then I should have all 7. Yes! All right. So that's it. That's a lot. 31 minutes, 32 minutes. Thank you for watching. If you made it this far, thank you. Give just a nice like, just so I can, maybe give it a thumbs down. I don't know. Just interact, comment, say something positive.